For our final video in section 3.1, we're back at the track. Here's a scatter plot of the sprint time and jump distance data from earlier. The correlation R is equal to negative 0.84. So our problem that we want to do is interpret the value of R in context, and then what effect does a point highlighted in red have on the correlation. Now this is just the same data that we looked at before. Same scatter plot we've been working with. I know that doesn't come through so clearly on the screen, but that is our red value that they are referring to. So first, before I go through interpreting R, I want to make sure you guys know how to do that in the calculator. Now, I don't know if you're getting the best picture there. Let's see. So if I do second catalog, which is down here at the 0, I want to turn diagnostic on, so I'm going to press alpha, and then I'm going to press alpha is your green button, and sometimes it's already on. If you look up here, it'll tell you if it's on or not. If you see an A, then you know your alpha is on. Then I'm going to press D, so I move to diagnostic, which is over here with the matrix button and our inverse function right there. And then I'm going to go down to where it says diagnostic on. Let's see, right there, diagnostic on. I'm going to hit enter and enter again until it says done. Now I've turned it on so my calculator will find R and R squared for me. After I've done that, you don't have to do this every time. Once you've done it once, you've set it up so you don't have to do it again. So do it one time and then it's good to go for the rest of it. I'm going to go to Stat, edit my list, make sure all of your data is in a list. This is the data that we looked at before. I'm sorry I don't have it here in front of you, but again, just walking you through the calculator function. So I put all my data in here into my list. Then to run linear regression, I move over to calculate. And I always use 8. Notice number 4 is a linear regression and number 8 is linear regression. The only difference is the way it's written. Now in 4, it's the way you're used to your mx plus b, your slope times x plus your y-intercept. The reason I use number 8 is because the way that your your book and your resource packet has it written. So I always go to 8. My X list I put in L1. Pay attention to where you put your explanatory variable. Y list in L2. I don't have a frequency list. If you would like to store your equation, meaning you want to look at it on your graph, or you want to be able to pull it up and evaluate the function, you can store it by pressing vars. Move over to yvars, hit enter on function, and enter again. And you have y1 go in there, so now it's going to be stored into y1. Then I'm going to go down and hit calculate. Because I have turned my diagnostic on, I get my A, which is my y-intercept, my B, which is my slope, I have my R squared value, and I have my R value. So notice they're giving me that value. You did not have to do this. It was already given to you. I just wanted to make sure you understand how to find it. So with our R being negative 0.84, we know that it's negative, which means, as we thought, as our sprint time decreases, our long jumps increase. The sprint times decrease, our long jumps increase. The slower you were running, the shorter your jump was. The interpretation of our R value is just to confirm that we do in fact have a strong negative association between sprint time and long jump distance. So because this is the absolute value of R is close to 1, that is what refers to the strength. So when we're talking about strong, because it is negative, we have that negative relationship. And then we're only going to speak of R values and the value of R values if we already have a linear function, or if we can already see that it appears to be linear. Later on, we're going to learn about residuals and residual plots to further double check whether or not we should be using a linear or if a linear is appropriate. Okay, then for part B, it says, what effect does the point highlighted in red have on the correlation? And it asks you to explain that. So again, I think we talked about this in the last video. That point is higher than we would expect it to be. So if I eyeballed what I thought the line would look like, I would say it looks something like this. You can tell this value is farther away than we would think it to be. And if I show you that real quick on the graph, well, there you have the answer. Because the highlighted point is a little higher than expected based on the pattern of the rest of the data, it makes the correlation closer to 0. It's pulling it away from being a tight line. The correlation without this point included is r equal to negative 0.87. So if we ran the correlation with that there, we would have negative 0.87 instead of negative 0.84. But if I go back here to my calculator, and if I looked at, so to create a scatter plot on the calculator, you go to second stat plot, and then I'm going to turn it on, and this time I'm going to go to the one that looks like a scatter plot, which is that very first one. I have L1, I have L2, and then I'm going to press zoom 9. Now the reason you see that line going through there is because we stored our equation. So now if I hit y equals, I can see my equation written out here. If you don't store your equation, you won't see the line on the scatter plot and you won't see the equation in here. So again, if I go back to my graph, I can find that point again by hitting trace, and I can move through these points, or I can specify which x value I wanted. That's the point that's far away. I have an x of 7.25, and I can see that it's higher than I would think it would be. Again, we can run it and see what it looks like without it, but we can talk about it, interpret fine without. So again, knowing how to use your calculator is pretty huge here, but interpretations are going to be key, being able to explain. It takes a lot of time to draw a scatter plot by hand, so a lot of times it's already going to be given to you, and you're going to need to be able to explain it and interpret it.